And then the another feature of the Java is that it is robust. Now, when we say robust, that is quick, that is fast. Now, the reason the language is robust is because it has got the automatic garbage collection mechanism, which prevents the memory leak, type safety of data. That is, in an integer, you should be able to store integer value. And if in case if you have declared float data type, you will be storing only float value. You'll not be allowed to store any other value other than that. And if you see over here, automatic garbage collection from this figure, memory whichever is not required, the memory whichever is not in use by the program, we have got the garbage collection mechanism that will pick up that will release that memory. I repeat, in the previous programming languages, let's say for C and C++, we have got malloc and malloc new ending for managing the memory. So memory management has to be done by the developer. If you have allocated 10 MB of memory for your program, then you need to track how much memory you have allocated, and then you need to delete that much amount of memory. But whereas in Java, if you observe over here, you can allocate the memory, but you need not write the code to delete the memory or to release the resources. Once its job is done, once the work is done, you have the garbage collection mechanism that will automatically release the memory that is not unused by the program. So that is what we call it as automatic garbage collection. An instance of compile and runtime checking. So it will check for the type safety about the objects that you're using, whether you're performing the type operation at the compile time as well as runtime. And one of the most important concept what we have is what we say as exception handling mechanism. So over here, I'll not discuss in detail about the exception handling, just a brief idea. Now your program will start when it will execute and start executing from start to finish. But there is a possibility that it might crash somewhere in between. So if the program is executing successfully from start to end, it's well and good. If in case of the program fails somewhere in between, then you should have a process to recover from that. So Java provides with the robust exception handling mechanism with a predefined set of classes that will help you recover from the programs. Just simple example for that. Let's say you've got the command prompt and let's say you've got a new program and over here is it fine now? Okay, let me boost this. It's completed with 30 DP. Okay, now let's see if you want to switch from one drive to the another drive, on typing the name of the drive that does not access CD Artica. So it gives the message saying that system cannot find the path specified. That is, this we call it as an exception. This we call it as an exception. Dot dot if you say, and then if you type dir, you will have the various drives that are listed over here. Now, successful execution is I'm typing cd space public and I am able to switch it. This is successful execution. The unsuccessful execution is cd and then you're typing some name that does not exist. Let us say x6, and this folder does not exist. So our command prompt is not getting crashed. Over here the command prompt is now not crashed. Rather it is giving a user-friendly message saying that system cannot find the path specified. That is, the folder does not exist. So it is helping you to recover from the error. That is helping you to recover from the error. So that is what the Java does. It will provide you with a robust exception handling mechanism that will help us to recover from the error. Rather than crashing the program, it will help you to recover from the error. And the example over here what is shared is divide by zero exception. Very simple. Let us test this with the help of the calculator. Now we have a calculator over here and we're trying to do 10 divided by 2. Good. It gives you the result 5. Now let us try to divide it by 0. 10 divided by 0. So when you're trying this 10 divided by 0, it is giving the error message cannot divide by 0 exception. Actually, we cannot divide the number by 0. So when you're trying to do this, it gives the error message. So that is being handled. It does not crash the calculator. Rather, it is giving a user-friendly message saying that you cannot divide the number by 0. That will help us recover from the exception. Let me go back to the slideshow. Now, then Java, it is architectural neutral. Java language, it is both, it is compiled as well as interpreted. Now let us have a look at the compilation process as well as execution process in Java. Now we write the source code over here and then source code is submitted to the compiler. Once the source code is submitted to the compiler, it generates the Java bytecode. It generates the Java bytecode. Now this Java bytecode that is generated, it is system independent. It is system independent. Now once it generates this, then you can take this code and you can execute on any of the platform. You can execute it on Solaris, you can execute it on Linux, you can execute it on Windows Workstation. That is, if you observe over here, you are just writing it only once. You're writing the code once and you are able to run on n number of platforms, 1, 2 and then 3. So that is what is Java's slogan, write once and then run anyway. You just need to write your code once and you will be able to run that on any of the platform which is got the JRE installed. So is this clear? Okay, thank you. Now Java is powerful because it will provide you with the rich standard libraries. With the help of which you will be able to write the programs quicker. You don't have to develop the libraries from the scratch. So networking, threads, distributed objects, libraries to access the database for 2D graphics, for 3D graphics, a library for the collection, serialization, digital signatures, and many more libraries are provided with the Java. And Java is popular, we know it. And again, one of the most important features of the Java is that it is distributed. Internet and the Java it became popular in the same era. The reason for Java being so widely used across the internet is because Java is distributed in nature. That is, you just write the code once and you can run it on any platform. Now, over here if you observe, when the internet started growing, we expected that the programs to run on the multiple devices. So if you are sharing the program over here on your internet, We expect this Java program that is available on the internet to run across various platforms that are all together running on the hardware, different hardware and in the software. So you expect all this. And so you can transfer all the code from this your server machine to the clients as bytecodes. And this bytecode, it can run any of the platform provided it has got the JRE installed. And then Java is multi-threaded in nature. Built-in multi-threading is provided by the Java. Multi-threading is called as parallel computing or parallel processing. These days, as we are getting the CPUs that has got the high processing power. Now, in order to utilize the CPU to the maximum extent possible, we have got multi-threading or parallel computing. Parallel computing, it is a process wherein you can execute more than applications at a time. Our CPU, it supports multi-threading. Now, just a simple example in multi-threading. Now, let's say you've got the Winword application that saves the document every 10 minutes. Now, let's say you're having a typing tutor. Now, it is a single application. Let me just go to the typing tutor. Okay, typing test something. Now, over here, if you're typing, so again, this is multi-threaded in nature. Okay, move. Now, this application, it is multi-threaded in nature because it is accepting the input from the user as well as it is highlighting over here. So, at a given instance of time, we have got more than one task or more than one operation that is being executed parallelly. One is it is accepting the input from the user, and the other one is it is highlighting what needs to be typed. So this comes under multi-threading. Now let us take an example wherein you are downloading some application. So downloading an application always takes place on a background thread. In the background will take place, and in the front end, let's say you are listening to some music. So on your mobile platform, at the back end, there is some download in progress, and in the front end, you are listening to some music. So we have got more than two tasks that are being executed parallelly. So again, this is one of the examples for multi-threading. I hope multi-threading is clear. Okay. So thank you. Thanks everyone for your quick response. Now next, starting with the Java editions. Java comes in three major editions: Standard Edition, Enterprise Edition, and Micro Edition. Now your Standard Edition is JSE, Java Standard Edition. Formerly it was known as J2SE, but now it is changed to JSE. Now using JSE, you can create the standard desktop application. Desktop programming can be done with the help of Java. Now some of the applications area wherein Java is used is JavaFX, in Java Swing, and in the big data. These are the other application programs that makes use of the Java. JavaFX is for graphics, and Java Swing is for creating the GUI components, and whereas big data is used for analysis. Business intelligence and all, we use big data. And then Java Enterprise Edition, formerly it was known as J2EE, but now it is JEE. Now using JEE, you will be able to create the server-side applications. Now the very basic for that we have is your servlets and the JSPs. And after that, many technologies and many frameworks have evolved and come into picture. And servlets and JSP is the basics. And then EJB we have got JNDI, JMX, and then various other technologies, RMI, CORBA, various technologies we have in this. So JSF prime faces EJB, Spring and Hibernate. Some are used for creating front-end stuff. Some EJB is used for creating the distributed application, and Spring and Hibernate it is used for creating the server side as well as the desktop applications. And Spring, Hibernate, JSF and all will come under frameworks. Anyway, we will be discussing about all these technologies and some of the websites that are built using Java. And then finally we have JME, Java Micro Edition. So Java Micro Edition, it is used for creating the application that has got limited processing power. For small devices, for embedded devices, we make use of Java Micro Edition. Now the virtual machine of the Java JME is called as kilobyte virtual machine, because all these devices has limited processing power and speed and RAM. So by taking this into consideration, a new platform has been devised that fits into these constraints. That is, the program that is written for these platform, they should not use huge amount of resources. It should be able to operate within the limited set of resources that are available. So we have got examples like BlackBerry. In Android, yes, to develop the Android applications we use Java, but it is an optimized version of the JSE. Cell phones, embedded devices, Java phones we have got the Java software that is written for the mobile phones, embedded devices and printers. Now Java was first publicly released in the year 1996, and then with each release new features were added to the language. And as of now, the current version of the Java is Java 8, released in 2014. It is not, and for each and every release, some name was given to the language as for the version, as we give it to the Android, like Jelly Bean, Marshmallow, Kit Kat, Lollipop. That is, for each release of the Android, one name is given after the desert name for the Android. In the same fashion, at each and every release of the Java, a name was given, and this practice of giving the name to the versions of the Java was continued up to 7. So 7 was called as Dolphin, and from 8 they have stopped the practice of giving the name to the language. Now we have got Java 8, and we don't have any name for that. They have stopped the practice of giving name to the versions. Now, in order to develop the language, you require JDK. JDK stands for Java Development Kit. So JDK will consist of all the tools and the components that are required to compile, build, and execute the Java applications. The most common tool what we will be using is the Java compiler and the Java interpreter. Now, before we start executing the program, first let us understand what is JVM and what is JRE. JVM, it is an abstract computing machine. Now over here you've got the Java source code. Let me take a simple diagram for this. Now over here, if you see, we have got the Java source code, and once the Java source code is submitted to the Java compiler, then you will get .class file. And this .class file, you will submit it to the Java virtual machine. This one is submitted to the Java virtual machine. And we have got the interpreter that will take care of converting the machine-independent code to the machine-dependent code. And this code is then submitted to the JRE to execute. Now, it generates this bytecode file. So this bytecode file is machine independent. This bytecode file is machine independent. Now what we do is then this bytecode is submitted to the Java virtual machine. So Java virtual machine, it will interpret the bytecode, it will check the correctness of the bytecode, and if it verifies it to be correct, then this code is submitted to the Java interpreter. And Java interpreter does the job of translating the machine-independent code to the machine-dependent code. If you see for this specific operating system, machine-independent to the machine-dependent code, then this machine-dependent code is given to the JRE, this bytes. So machine-dependent code is given to the Java runtime environment to execute. Is this clear? I repeat, we have got the Java source code that is submitted to the Java compiler. This Java compiler will generate the bytecode. This Java compiler will generate the bytecode. This Java bytecode that is generated, it is machine independent. Means it can run on any of the platforms. It can run on any of the platforms. Now, in order to convert the machine independent code to the machine dependent code, we have got the Java virtual machine environment. Java virtual machine will interpret this code, machine independent code, and it will convert it to the machine dependent code, operating system specific code. And then this code is then submitted to the JRE to execute. Here it starts executing. Now over here again you see, you've got the Java bytecode that you are submitting it to the Java virtual machine. One is for the Windows, one is for the Windows XP, other one is for the Red Hat Linux, and CPU architecture is again different. This one is executing on Intel and the other is executing on the AMD platform. So once the code is submitted to the Java virtual machine, this code is transferred to the machine specific format. So this is machine independent code. So machine independent, this code should be translated into the machine dependent format, to the CPU specific, to the OS specific format. So this is done by your Java virtual machine. So it translates the code from machine independent to machine dependent. And then it starts executing. And then this machine dependent code is submitted to the Java runtime engine, and then it starts executing the code. So is this clear? Is this diagram clear? Okay. So that was a simple diagram. come back to this. Now then next let us discuss about the object-oriented programming itself. What are the features of the object-oriented programming? So object-oriented, it is a methodology. It is a methodology or it is a paradigm to develop the programs. As we have procedural programming in which you will develop the programs or applications around functions. In procedural language, we develop the applications around functions, whereas in the object-oriented methodology, we develop the applications around objects. It is a programming paradigm using which you can develop the applications. We will be discussing about the advantages and then the features that are offered by the object-oriented approach. Now, all the principles of the object-oriented programming language are designed from the real-time principle. So, in the real time, if you have a look around the objects, everything we classify into two types, living entities and the non-living entities. In the object-oriented programming, everything we consider it as an object. Now, over here, what we have is, in the object-oriented programming, it will map the real-time objects to the software objects. In the object-oriented programming, we map it to real time. We map it to real time. So, let's say you are developing a simulation game for a car racing application. You're developing a simulation game for a car racing. Now, in that what we do is how the car behaves in the real time, the same way we map it to the graphics card. So it maps to the real world objects, graphic card is mapped to the real car. And it revolves around objects and the classes and objects can communicate with each other. And we have got the software that is divided into modules and arranges the object in the hierarchy. Now before we discuss all this, let us discuss about what is an object and what is a class. Okay. Let me take help of Notepad. Now in the real time what we do is everything we consider it as an object. As a real time entity that has got some characteristics and behavior. Let us demystify this. Now, let us assume, now if you look around the world, everything you will consider it as an object. Everything we consider it as an object. Now in real time, if you see any object or if you see any entities, it has got something. It has got two things. It has got some properties and it can perform some operations. It has got some properties and it can perform some operations in real time. Now, let us take an example for a car. So what are the properties for the car? Let's say the properties for the car is like color, its speed, brand, engine CC, etc., etc., etc. This all will come under properties. And what operations it can do? Basic operations, you can drive it. You have got steering, you can steer it. You can apply brakes. You can change gear, etc., etc., etc. Now that is what, if you see in the real time, if you observe any entity, it has got two things. One is properties and the other one what we have is operations. Now, this is again, if you map this to the software object, so we will create one object called car which has got so and so properties and so operations. Now let us assume you are creating some convex application. So what are the properties for that? Let's say one is 2, so what can be the another? What do you want to say for the contact stuff? Correct, name, let's say correct address, number, correct. So these all will become the properties. And what could be the operations for this one? Correct. And operations can be like, you can add, you can edit, delete, correct, modify is edit, and then you can share it, you can send it. So this all can be the operations for this one. So the concept of the object-oriented programming is, in the real time, each object will have certain properties and certain functions. In real time, if you observe the objects, each object will have certain properties and certain functions. So we have mapped this concept of real-time programming to the software programming. So in the software, when we are creating the objects, we map this. So we create it in such a way that, again, it has got two things. It has got some properties and it has got some functions. It has got some properties and it has got some functions. So that is what we say we are mapping these real-time objects to the software objects. Now, let us take an example of the simulation game. Okay, so let us pick up this. I hope it's free. Just to understand it better, let us demonstrate this. Oh, it's taking huge time. So in real time, how do we differentiate one entity from the another. In the real time, how do we differentiate one object from the another object or one entity from the another entity? So simple. Let us say, okay, how do you differentiate a bat from a ball? Or let's say, how do you differentiate a pen from a book? So how do you differentiate? Correct, Amrita says based on the characteristics. Yes, based on with the help of the properties. Correct. So with the help of the properties and with the help of characteristics in the operations, we differentiate one entity from the another. So bat you differentiate from the ball because you find that there is a change in the characteristics and in the operations what they perform. So similarly in the object world also, you will differentiate one object from the another object based on their characteristics and in the behavior. Thanks Amrita and Shamita for your response. I think over here it has started. So flip driving something. So how many objects you find over here? On this game screen, how many objects are available? Now this diver is one object. See over here. Now over here if you see, how we perform the things in the real time. Now over here they are specifying some list of drivers. You can select even n number of drivers. So again this is one object, this is one object. So over here you can find these are all the properties, difficulty, jump, rotate, etc. etc. So let us select any one. Oh, here is the one set. Okay. Now so over here if you see as how the stuffs behave in the same in the real time, the same way we are mapping it to the object-oriented programming. So as we have identified, you have got various objects. This is one object, and this is something. This is the another object. You have got a coin over here. This is the another object. You have got a ladder over here. That is the another object. So how the stuffs behave in the real time, the same way we are trying to simulate and then map it to the object-oriented programming. Now, as you see over here, your application is a collection of classes, sorry, objects, and your application is a collection of classes. And we have identified the way we differentiate one object from the another is based on the characteristics and the properties. Now next what we have is class. So class is logical and whereas object is real time. Real time entity or real time instance. Now let us just discuss this with a simple example. We've got various applications that are installed in the system. Now, if I right click and select the task manager, I'll get the list of applications that are running. Now, let us in this. So this is gone. Now, over here what we want to discuss is, so this is called as an instance of Chrome. This is called as an instance of Chrome because it is occupying some memory. You've got an instance of the GoToMeeting. You've got an instance of the Microsoft PowerPoint. You've got an instance of the Notepad and so on. Now we also have the WinWord available. WinWord available in the system. But it's not running. It's not running. So if you go to your program files, so you have got the WinWord over here. What is that? Microsoft Office, and the Microsoft Office, okay, you will find all this stuff. So you've got PowerPoint and all this stuff over here available. But as of now, it is not running. So the code what is available over here, this code we call it as logical code. This code, this complete code what you have is logical stuff. This code is logical. Now let us start the application. Now this code is logical, and using this code, this is the actual stuff what you see, this is an object. So you can say this is an object. This is an object of WinWord. So the stuff what you see in the real time, the stuff what you see in the real time is an object. So using logical, you're creating objects. So using the logical code which is available in the system, we see an object or we see an instance of the notepad. So the code is a logical because all the code, whatever files are there, compiled files, it gives the instruction to the operating system how to create a WinWord application out of this. So the code what we have is logical, and using this logical code, the stuff what we are seeing this, the WinWord window what we are seeing over here is an object. So object is a real time, it occupies memory, it occupies some computing power and some CPU time. So let us have a look at the task manager. So if you see over here Microsoft Office Win32-bit, it occupies some memory, CPU cycles, memory, some disk space, and if it is taking part in the networking operations, then it will occupy some bandwidth as well. So logical is the code what we have, so and then the object is the stuff what you see in the real time. Now, so how many instances of Notepad or how many objects of WinWord you see now? How many objects? 2 objects, correct. So we don't have, okay, you need not install the Microsoft Office twice. You will need to just have the logical structure once, and using which you can create multiple objects. This is one and this is another. And each object will have its own state, behavior and all. Now this one is object 1, and this is object 1, and let's say this is object 2. So when we say state, the data, each object will have the data. Now you may write over here, welcome, and let me just I'm just changing this. So it has got its own state, and let me insert the header for this also. So I'm selecting some different header for this. So this object has got its own header, this object has got its own header. So each object will have its own state. Each object will have its own state. The state of an object will vary from one to the another. It is independent of the other. So state, this one, okay, the data represented by the object is called as state, whereas this will come under operations. So how many operations you find over here for this? For the Winward objects, how many operations we find over here? One is info, new, open, save as, print, share, etc., etc., etc. All this will come under operations. All this will come under operations. So object has got two things. One is state and the other one is behavior. One is state, the other one is behavior. State is represented by the data, whereas operations that an object can perform is represented by behavior. Or behavior is represented by operation if we see it other way around. So is the difference between the object and a class, is it clear? So we've got two things, one is class and the other one is object. So class is a blueprint and it is logical, whereas the object is real time. Now this Chrome window, what you're seeing, is it an object, real time, or is it a logical structure? The Chrome window, what we are observing over here, is it logical or is it a real time entity? Correct. Object, that is an object. Yeah. L3 if you are correct. Amrita, Sharmista, and Shruti. Yeah, Sharmista, please go ahead with the question.
Yeah, I think actually you told that the data for the two objects will be different, but I think the operation or the behavior will be the same.
Yes.
Right? Okay.
You will get only one copy of behavior, but whereas all the objects will have their own copy of data. Absolutely correct.
Okay, fine. Thank you.
Okay, welcome. Now, is it clear with the rest of the participants also? Shaumya and Awad, is the class and the object concept clear with Awad and Soumya? Awad and Soumya, is the concept clear? Okay, thank you. Thanks for your response. So as we have discussed, class, it is a blueprint. It is just a logical structure. It is just a logical structure, and it just consists of the code. It might have some files. So using which the program execute. So let's say you've got Microsoft Office folder wherein you're having the files, and these files you submit it to the operating system, Windows operating systems. You submit this files, the logical code is submitted to the OS, and using this it is creating the object. Let me use this. So it is using this, it is creating this object. So this is how it works. So files, what we have, it is only logical set of instructions. That is just logical piece of instructions. So that is submitted to the OS, and using which you get the objects. Now similarly, when it comes to the Java, we've got two things, class and then the object. We've got class and then the object. So class is the code what you're writing. Code what you're writing is class, and that we call it as logical. And when your program is executing in the actual window, what we see is an object. Let me run this now. Again, the same example, but we have discussed messages. You have got two text, and the operation would be perform as send SMS, forward, and cancel. And using one class, you're creating multiple objects. One is object Tom, and in the other one object is Jack. And as discussed, each object will have its own data. Over here, you're having something 1, 2, 3, 4, some number, and then Tom. And over here, it is having its own data. So is this clear? Using one class, using one logical structure, you can create multiple objects. That is what we do. We have got the messaging application installed, that is the logical structure, and using that we create multiple objects. And each object will have the data of its own. Each object will have the data of its own. Operations, technically speaking, only one copy will be allocated for the methods. One copy will be allocated and all the objects will use the same copy of methods. So just to answer your question, when you start executing JVM, it will allocate 5 different memory structures. Among them, one is method area. So the copy of the method will be available on the method area to which the object will have an access. Only one copy will exist. See over here. Now in function-oriented programming, or in the functions procedural style approach, we have got the functions that will communicate with each other. One function will communicate with each other in the function-oriented programming. Let's say okay, you are having a function. This is function 1, and then you have got function 2. So in function-oriented programming, as we discussed, the code will revolve around the function, or the application is built around functions, and one function can communicate with the another function. Function 1 will communicate with the another function, function 2. Whereas in the object-oriented programming language, the code is built around objects. So you have got object 1 and then you have got object 2. One object can communicate with the another object. Object 1, it can communicate with the another object by passing messages. One object can communicate with another object by passing the messages. Let us take some simple example. Let's say you are developing a simulator application for elevator, and you have got door and you have got button. Both are two different objects. One object what we have is door, and the other object what we have is button. So we can say the button will communicate with the door. That is, when you press the button, it will send a signal to the door either to open or close. I repeat, in the object-oriented programming, we have got the objects that can interact with each other. Just to map this to the real-time example, let's assume you have got an elevator wherein we have got two objects. One is button and the other one is door. So button will communicate with the door with the help of signals. So at the press of the button, the door will either open or close. So we can say that the button is communicating with the door. So in the object-oriented programming, one object can use the another object, or one object can communicate with the another object by passing messages. Is this concept clear? Okay, thank you. This anyway we have already discussed. Now all the advantages of the object-oriented programming and all, we will discuss this in the next class. But with this, let us